Understanding pavement distress and rehabilitation. It is impossible to find people who have not seen any distress, cracking, or deformation in the pavement. Pavement is designed based on the consideration that it will fail, show cracking or deformation after few years of service. The pavement is then repaired regularly or periodically to monitor the level of damage or to provide the expected quality of service. When any or more of the distress levels exceed the threshold, limiting value, the pavement is considered failed and rehabilitation is recommended. This chapter discusses different types of distresses, their causes, and possible measures to control them. Almost all types of distresses allow moisture to penetrate into the pavement and deteriorate the pavement structure, and subsequently decrease the pavement's serviceability and quality service life. 4 major distresses are considered while analyzing and designing flexible pavement. These are alligator cracking, top-down cracking, rutting, and transverse cracking. Series of interconnected cracks looking similar to a chicken wire or back of an alligator, as shown in Fig, are defined as alligator cracking. This crack is initiated at the bottom of asphalt layer due to the damage caused by the developed tensile strain induced by the repeated wheel load. With increase in severity, the cracking propagates to the surface. This is why this crack is very often called bottom-up fatigue crack or simply fatigue crack. However, some agencies use fatigue crack for both bottom-up fatigue and top-down fatigue cracks. Therefore, care should be taken while using the term fatigue crack. Causes. Crack initiates at the bottom of asphalt layer due to repeated tensile strain caused by wheel loading. Ashto, 2015. It propagates upward and appears at the surface as several short, longitudinal, or transverse cracks in the wheel path and interconnects laterally with continued repeated fatigue loadings, forming many-sided sharp-angled pieces that develop a pattern which resembles the skin of an alligator or the shape of chicken wire. This crack occurs because of thin pavement or pavement with weak base subgrade, excessive loading, or combination of these. Other factors such as poor drainage accelerate the progress of this crack. Treatments. Full-depth rehabilitation is the best option to get rid of large cracked areas. As alligator cracking starts at the bottom of asphalt layer and propagates upward, replacing a part of the asphalt layer or overlay does not eliminate this cracking. However, replacing a part of the asphalt layer or overlay be used for low-severity alligator cracking to defer the high-severity cracking for few years. Understanding top-down, longitudinal cracking. Longitudinal cracks near the wheel paths, parallel to the centerline of the roadway, are called top-down longitudinal cracks or longitudinal cracks. Figure shows the photos of top-down longitudinal cracks. Crack initiates at the surface of asphalt layer due to repeated tensile and/or shear strain caused by wheel loading. Ashto, 2015. It can also develop along the construction joint between adjacent passes of the paver or at a location that corresponds to the center of the paver. A thin layer of asphalt may be replaced if the cracks do not penetrate to full depth of asphalt layer. Otherwise, full-depth rehabilitation may be required. 2 major options are available to mitigate or avoid top-down cracking. The first one is improved heavy vehicle loadings control, and the second is improved asphalt surface courses. Understanding rutting and pavement. Rutting. Rutting is the longitudinal surface depression in the wheel path resulting from permanent deformation in each pavement layer along the wheel path. Ashto, 2015. Ruts are particularly evident after a rain when they are filled with water. The rut depth is the vertical difference in elevation between the transverse profile of the surface and a wire line across the lane width, as shown in Fig. As the rut depth increases, the amount of water ponded along the wheel paths increases. It causes a reduction of surface friction and increase of hydroplaning. Causes. Rutting occurs in 3 basic ways. Wearing of asphalt surface. Vertical deformation of layers, also called structural rutting. Shear deformation of asphalt layer, also called instability rutting. Wearing of asphalt surface is the progressive loss of material from the roadway surface due to poor quality asphalt mixture, studded tire, and inadequate compaction during construction. Structural rutting is the sum of permanent vertical deformations, densification or deformable materials, of all pavement layers due to repeated traffic loads. It occurs due to less stiff materials and low thickness of layers. Improper compaction or mixed design, such as high asphalt content, excessive fines, and insufficient amount of angular aggregate particles are responsible for rutting. Shear rutting is the lateral shear displacement of asphalt materials under wheel loading. The hot mix asphalt, HMA, is displaced downward, laterally, and then upward to form ridges on either side of the wheel paths. Unstable asphalt layer or too less air void leads to shear rutting. Treatments: small amount of rutting, less than 1/3 in. 8.5 mm deep can generally be left untreated. If the depth is more than 3/4 in, 19 mm, milling out certain depth and replacing it with better rutting-resistant asphalt may be the right option. ARA, 2015. If the rutting is due to the base subgrade layer, then full-depth reclamation is the only option. Understanding transverse cracking in asphalt pavement. Transverse top-down surface cracking, also known as transverse cracking or thermal cracking, of asphalt pavement is one of the important distresses especially observed in cold regions. Thermal crack consists of two types of cracking, namely the thermal fatigue cracking and the low-temperature cracking. Repetitive thermal cycles may cause thermal fatigue cracking, even though the amplitude of the temperature cycle is not so severe. Single cooling due to extreme cold temperature or high rate of cooling may cause low-temperature cracking. Ashto, 2015. Low-temperature cracking occurs when the induced tensile stress exceeds the tensile strength of the asphalt concrete. A transverse crack, also called a thermal crack as it is not load-related, runs perpendicular to the pavement's centerline or lay-down direction, as shown in Fig. This is caused due to single-day extreme cooling of pavement or cyclic cooling heating loading. It allows moisture infiltration and causes an increased roughness. Causes: transverse cracking occurs due to shrinkage of the HMA surface as a result of low temperatures or asphalt binder hardening. Proper selection of asphalt binder considering the possible single-day extreme low temperature may avoid the transverse crack. Treatments: based on the crack depth penetrated, a thin or the full depth replacement may be required. Understanding minor distresses in pavement design. Minor distresses. The above discussed 4 major distresses are considered while designing the pavement. There are some minor distresses which are considered for asphalt mix design and maintenance and rehabilitation operation. Stripping. Definition: stripping is a moisture-related damage, the loss of bond between aggregates and asphalt binder beginning at the bottom of the HMA layer and progressing upward. It is very difficult to identify stripping as it starts at the bottom of asphalt layer due to the presence of moisture, and when it reaches the surface, it accompanies other forms of distress, such as rutting, shoving, corrugations, raveling, or cracking. Coring is the only option to identify stripping. Figure shows 2 candidate pavements with stripping. Full-depth coring is required to confirm these are stripping. Causes: infiltration of moisture and poor drainage of moisture are the primary causes of stripping. Treatments: repairs in both asphalt layer and underneath base subgrade are required. Thus, full-depth reclamation is the only remedy for stripping. Stripping may be avoided with proper drainage system and by sealing cracks regularly. Causes: infiltration of moisture and poor drainage of moisture are the primary causes of stripping. Treatments: repairs in both asphalt layer and underneath base subgrade are required. Thus, full-depth reclamation is the only remedy for stripping. Stripping may be avoided with proper drainage system and by sealing cracks regularly. Understanding raveling in pavements. Raveling is the loss of bond between aggregates and binder starting from the surface and propagating downward, as shown in Fig 8.6. It causes loose debris on the pavement, increased roughness, loss of skid resistance, and so on. There may be several causes for asphalt raveling: loss of bond between aggregate and binder. Presence of dust in aggregate particles allows the asphalt binder to bond with the dust rather than the aggregate. If there is shortage of fine particles, the asphalt binder is only able to bind the remaining coarse particles at their relatively few contact points. Adequate compaction is required to allow bonding between aggregate and binder. Studded tire may break the bond between aggregate and binder. Small raveling may be fixed by patching, microsurfacing, or chip seal. Large raveled areas require the overlay or surface replacement. Understanding potholes. Bowl-shaped depressions in the pavement surface penetrating all the way through the asphalt layer down to the base course are called potholes. They are generally circular, with diameter less than 30 in, 750 mm, and depth greater than 3/8 in, 10 mm, and have sharp edges and vertical sides are near the top, as shown in Fig 8.7, ARA, 2015. Serious vehicular damage can result from driving across potholes at higher speeds. Potholes occur due to poor quality asphalt mixture, low asphalt binder contents, soft aggregates, etc., or construction deficiencies, low compaction, mix segregation, etc., or structural problems, insufficient pavement thickness, reduced base support, etc., and environmental conditions, freeze-thaw cycles, etc. Sometimes, potholes are the result of alligator cracking. As a vehicle runs over severe alligator cracking, the interconnected cracks create small chunks and they take off. Potholes are fixed by patching or filling. It consists of removing the loose materials, cleaning the potholes, applying some tack coat, prime coat if base is exposed, applying the mix, hot or cold, and compacting. Understanding bleeding in pavement. Bleeding is a flushing film of asphalt binder on the pavement surface, looking shiny and glass-like reflecting surface, as shown in Fig 8.8, that can become quite sticky. Bleeding areas have less skid resistance, that is, they are slippery especially in wet weather. Bleeding is not a reversible process. This means asphalt binder accumulates on the pavement surface over time and does not go down. Bleeding occurs when asphalt binder fills the aggregate voids during hot weather and then expands onto the pavement surface. Brown et al., 2009. This can be caused by one or a combination of the following: improper mix such as high asphalt binder, too soft asphalt binder, low air voids, etc. Construction deficiencies, excessive tack or prime coat, etc. Environmental conditions, excessively hot weather, etc. Traffic effects, high traffic volumes, etc. Minor bleeding may be corrected by applying coarse, hot sand or grit to blow up the excess asphalt binder. Major bleeding can be corrected by removing a thin layer and resurfacing. Understanding block cracking in pavements. Block cracking happens when interconnected cracks divide the pavement up into rectangular pieces. The blocks may range in size from 12 in by 12 in, 300 mm by 300 mm, to 10 feet by 10 feet, 3 m by 3 m, as shown in Fig. Block cracking is associated with shrinkage of the asphalt layer or the base subgrade materials and hardening of asphalt binder. Crack seal may prevent the low-severity cracks. High-severity cracks may be removed and replaced with an overlay. Understanding reflection. Cracking in asphalt overlays. Reflection. Cracking. Definition. Reflective cracks, Fig 8, are cracks in asphalt overlays, reflecting the existing cracks in the underlying pavement before the placement of the overlay. These cracks are larger than block cracking and can be longitudinal, transverse, or random depending on the pre-existing cracks in the underlying layers. Causes. Reflection cracking occurs due to stress created by the horizontal and vertical movement of the underlying pavement structure following the fracture mechanics rule. Treatments. Linear and localized cracks can be sealed. Replacing the layer is the solution if cracks are extensive and nonlinear. Use of reinforced asphalt, with grids, may be a way to avoid reflection cracking. Understanding pavement depressions. Depressions are localized lower elevations of pavement surface, as shown in Fig. Due to subgrade settlement or frost heave, they are readily noticeable after rain fills it with water. It causes an increased vehicle hydroplaning and accelerates the bottom-up fatigue damage process. Depression occurs due to frost heave or failure of subgrade, settlement, resulting from inadequate compaction during construction. Depressions of less than 3/4 in, 19 mm may be microsurfaced. Otherwise, they should be repaired by digging out and replacing the area of poor subgrade. Understanding corrugation and shoving in pavements. Corrugation and shoving is somewhat a ripple, corrugation, or an abrupt wave, shoving, on the pavement surface at points where traffic starts and stops, corrugation, or areas where asphalt abuts a rigid object, shoving, as shown in Fig. This is a form of plastic movement of asphalt materials perpendicular to the traffic direction and does not accompany cracking. Corrugation and shoving is usually caused by traffic action, starting and stopping, on less stable and less shear-resistant materials, which is because of the following reasons. Improper mix design such as high asphalt content, soft binder, excessive fines, mix contamination, poor mix design, poor HMA manufacturing, lack of aeration of liquid asphalt emulsions, etc. Possibly excessive moisture in the subgrade, sometimes leading to cracking. Repairing of corrugation and shoving is carried out following one of the two strategies. Small corrugation or shoving can be removed and patched with well-designed and properly produced asphalt, better to avoid cutback asphalt. Large corrugated or shoved areas are indicative of general asphalt layer failure. Removing the damaged pavement and overlaying may be an appropriate solution. Understanding slippage. Cracking in pavements. During braking or turning vehicles, pavement surface slides forming crescent or half-moon-shaped cracks with two ends pointed into the direction of traffic known as slippage cracks. Figure shows two slippage cracks. The left photo shows clearly that the two ends are pointed toward the direction of traffic. Slippage crack occurs in asphalt overlays with lack of tack coat or poor bond between the old surface and the new overlay. It also occurs due to excessive deflection of the underlying pavement structure under the compaction equipment or haul trucks. As the roller or truck passes, the surface of the pavement gets tension, forming the slippage crack. Removal and replacement of the affected area is the only solution of this distress. Understanding microcracking in pavement. Microcracking is usually 1 to 3 in, 25-75 mm long and 1 to 3 in, 25-75 mm, a part that appear on the mat surface during compaction of cold mat, as shown in figure. Microcracking is usually shallow, small, and not so detrimental to pavement performance. There are 3 major causes of microcracking. Excessive pavement deflection during compaction creates surface tension in mat, causing tiny fissures or cracks on the surface. Tender mixes tend to shove when compacted and create surface tension in mat, causing tiny fissures or cracks on the surface. Compacting cool mat shows microcracks as cool mat is stiff. The existing microcracks can be treated by applying microsurfacing, chip seal, or a thin overlay. For excessive microcracks, a thin surface may be removed and microsurfaced or overlaid. To avoid microcracking, the causes discussed previously should be avoided. ARA, 2015. Understanding water bleeding and pumping in pavements. Water bleeding means seeping water out of joints or cracks or through an asphalt layer. If seeping consists of water and some fine materials, it is termed pumping, as shown in figure. It causes a decreased skid resistance, an indication of high pavement porosity, water bleeding, and decreased structural support, pumping. Causes of water bleeding and pumping may include the following: porous pavement due to inadequate compaction, high water table, poor drainage. If the problem is a high water table or poor drainage, subgrade drainage should be improved. If the problem is a porous mix, in the case of water bleeding, a fog seal or slurry seal may be applied to limit water infiltration. Understanding polished aggregates. Polished aggregates are those that have lost their original surface texture and angularity due to abrasion action by tires, as shown in figure. Polished aggregates have a decrease in skid resistance, especially when they are wet. As a pavement ages, the protruding rough, angular particles become polished due to repeated traffic, as the aggregates are less abrasive resistant. The process accelerates if the aggregate is susceptible to abrasion or subject to excessive studded. Tire wear. A skid-resistant slurry seal or overlay can be applied to remove the polished aggregate. Understanding mat tearing in asphalt surfaces. Mat tearing is defined as the surface dragging defects, torn or streaked areas, that occur in the asphalt surface during the laydown and compaction operations. Torn or streaked areas may have higher air voids and are susceptible to decreased stiffness, reduced fatigue life, accelerated aging, decreased durability, rutting, raveling, and moisture damage. There are several causes of mat tearing depending upon the type of mat tearing or streaking. Some major causes are listed below. Warped or worn screed plates have the increased likelihood of dragging aggregate particles along the mat surface for larger friction and have more potential defects that can grab aggregates. A screed plate tends to tear the mat at the beginning of paving operations if it is not preheated. As the hot asphalt heats the screed, this type of tearing will generally disappear. If screed extension is not properly installed for its crown and elevation, it could create a small streak at the point of transition from screed to extension. High paver speed can stimulate small aggregate particle disturbances to the point where the result becomes a visible streak. Stacked aggregates caught between the screed and the surface being paved may roll or be dragged forward. Chip seal or thin overlay may be a solution for existing mat tearing. To avoid the mat tearing, the above-discussed causes are to be avoided. Understanding non-uniform texture in pavements. Causes. There are many potential causes for non-uniform mat texture. Many times, the same mechanisms can cause mat tearing and non-uniform texture. Therefore, an investigation of mat tearing causes is also warranted. The causes listed below are typical of the non-uniform texture. Segregation is one of the main causes of non-uniform texture. Temperature differentials may not allow proper mixing of aggregates. If the mixture is delivered at low temperatures, it is an indication that the mix might not have adequate time for compaction, which results in segregated mix. Handwork behind the paver screed generally involves depositing asphalt material on top of the mat in either thin layers or individual aggregate particles, and therefore detrimental to pavement appearance. Treatments. Small-scale non-uniform mat texture may be left untreated. Chip seal or thin overlay may be a solution for large-scale non-uniform mat texture. ERA 2015. To avoid the non-uniform mat texture, the above-discussed causes are to be avoided. Treatments. Small-scale non-uniform mat texture may be left untreated. Chip seal or thin overlay may be a solution for large-scale non-uniform mat texture. ARA 2015. To avoid the non-uniform mat texture, the above-discussed causes are to be avoided. Treatments. Chip seal or thin overlay may be a solution for existing mat tearing. To avoid the mat tearing, the above-discussed causes are to be avoided. Understanding pavement distresses. 4 major cracks have been discussed in section, and 14 minor cracks have been discussed in this section. Additionally, there are some cracks which are not so common but exist. Some of them are discussed here. Edge cracks. Edge cracks are parallel to roadway and occur within 1 to 2 feet, 300–600 mm, of the outer edge of the asphalt pavement with no or partially paved shoulders. This cracking is initially caused by lack of lateral support from the shoulder or base weakening due to poor drainage and/or frost action. Lane shoulder drop-off. Lane shoulder drop-off is a difference in elevation between the pavement edge and the roadway shoulder due to shoulder erosion, shoulder settlement, or the buildup of the roadway through asphalt overlays without adjustment of the shoulder level. Base subgrade problems. Poor drainage or inadequate compaction of base subgrade causes some major cracks, as discussed earlier. Some other forms of distresses, such as swells, bumps, and sags, also occur due to base subgrade problems. Swells are characterized by upward displacement of the pavement surface due to frost heaving or swelling soils in a long, gradual wave that is more than 10 feet, 3 m, in length. Bumps are usually less than 10 feet, 3 m. Sags are abrupt downward displacement of the pavement surface, initiated with loss or settlement of the underlying base subgrade. Sags accompanied by cracking are known as dipping or cupping. Joint separation. Joints are required between 2 sequences of construction. Sometimes, joints are provided between lane and shoulder. The widening of joints may turn into distresses if it is not sealed and moisture infiltrates through it. Figure shows an example of an extreme consequence of a joint separation. Understanding asphalt pavement. Distresses and treatments. Discusses the distresses that are frequently seen in asphalt pavements. Depending on the material, climate, composite layers, and local practices, other kinds of distresses are also possible. Some pavements may show a combination of 2 or more distresses. For example, a pavement with alligator cracking might have rutting or other kinds of distress as well. There may be multiple causes of these distresses. For example, alligator cracking may occur because of the following: thin asphalt layer, or heavy load on thick asphalt layer, or weak base subgrade with thick asphalt layer with normal loading combination of 2 or more causes. As an example, fugure. shows a pavement with alligator cracking, edge cracking, and rutting at the same time. The probable causes are base, subgrade deficiencies, and repeated loading. Regarding the treatment option, every highway agency is unique, and they have their own innovative strategy to repair these distresses. The application of treatment also depends on local materials, climate, budget, etc. The above-discussed treatment prescriptions are general in nature. Based on local needs, an optimum solution is sought out. In addition to general repair strategies, some repair and preventive treatments are summarized in table. Alligator cracking. Preventive treatments. Surface or fog seals and surface patches can help delay the progression of cracking. Understanding asphalt pavement distresses and treatments. Repair treatments. Full-depth repair is recommended for significant alligator cracking as it addresses the underlying issues. 2. Longitudinal cracking. Preventive treatments. Crack sealing can help prevent further damage. Repair treatments. If cracks do not go through the full depth, a partial depth repair is appropriate. 3. Reflective cracking. Preventive treatments. Sealing cracks and saw cutting above joints can prevent moisture infiltration. Repair treatments. Full depth repair is warranted when cracks are extensive. 4. Block cracking. Preventive treatments. Sealing cracks and applying a chip seal can mitigate progression. Repair treatments. A chip seal can be applied to repair block cracking. 5. Depression. Preventive treatments. No specific preventive measures are listed. Repair treatments. A leveling course or milling the surface can help correct depressions. 6. Rutting. Preventive treatments. No specific preventive measures are listed. Repair treatments. A leveling course or milling can be employed to address significant rutting. 7. Raveling. Preventive treatments. A rejuvenating seal can help maintain the pavement and prevent raveling. Repair treatments. Chip seal or surface seal can be used to repair raveling. 8. Potholes. Preventive treatments. Crack sealing can help prevent water infiltration. Repair treatments. Surface patching or full/partial depth repair is necessary for potholes. 9. Polished aggregate. Preventive treatments. Seal coats can be applied to maintain surface texture. Understanding asphalt pavement distresses and treatments. Repair treatments. A slurry seal, chip seal, or open-graded friction course may be used to restore skid resistance. 10. Slippage cracks. Preventive treatments. Improved mix design and better compaction during construction can reduce slippage cracks. Understanding asphalt pavement distresses and treatments. Repair treatments. A slurry seal, chip seal, or open-graded friction course can help repair slippage cracks. Joint cracks. Preventive treatments. Better construction practices can help prevent joint cracks. Repair treatments. Sealing of joints can mitigate the impact of joint cracks. 12. Corrugation. Preventive treatments. Better mix design and compaction practices can prevent corrugation. Repair treatments. A thin overlay can help smooth out corrugated surfaces. 13. Bleeding. Preventive treatments. Better mix design practices can minimize the occurrence of bleeding. Repair treatments. A chip seal can address bleeding issues.